This video is to help you prepare for your Unit 5 test, which is covering the things in geometry that we've learned in class. Number 1 says a rectangular prism is shown below. It says Fa drew a plane to slice the prism diagonally from the top front edge to the back bottom edge. Which figure was formed by the intersection of the prism and the plane? So if you draw a line that represents the line that Fa drew, you are drawing it from the top front edge to the back bottom edge. So something like this. If we were to split that apart and then look at the shape that was created, when you cut a rectangular prism in half, you should see a triangle. And you're going to contain a right angle in that triangle because rectangles are made up of right angles. So C is the correct answer here. We're going to use the following to answer numbers 2 and 3. The fountain in the middle of a park is circular with a diameter of 16 feet. There is a walkway 3 feet around that surrounds the fountain. So if we go along what's stated there, the diameter of the circle, that's the fountain, is here. That's 16 feet. We have 3 additional feet on this side and 3 additional feet on this side. So if we're going to find the approximate area of the walkway, we want to know the area of only this portion that surrounds the figure. That means that we're going to have to find 2 different areas and then find their difference. So if we start by looking at the fountain, the area formula for a circle is area is pi times radius squared. We will always use something that everyone can get a consistent answer with for pi, so we're going to use 3.14. And that will be multiplied by the radius squared. If the diameter is 16, then the radius is half of that, which is 8. So 8 squared. And 8 squared is 64. So you're taking 3.14 and multiplying by 64. That gives you 200.96. Now we need to take a look at the walkway. You can't get the area of just the outside of that circle, so you have to find the entire area of the large circle, which again is going to be pi times radius squared. But if we had 3 additional feet here and 3 additional feet here, the diameter of the walkway is 22, which means that the radius is 11. So as we fill this in, it'll be 3.14 times 11 squared. 11 squared is 121, so 3.14 times 121. And 121 times 3.14 is 379.94. So now we'll take the area of the large circle and subtract the area of the small circle, and the remaining portion will be the area of the walkway. And that leaves us with 178.98, which rounds to 179 feet squared. In number 3, it says, suppose the width of the walkway is increased by 1 foot. By approximately how much would the area of the walkway increase? So I've listed out the important information that we had from the last question. The fountain's diameter was 16, the radius was 8. The walkway's diameter, or the large circle to get the walkway, was a diameter of 22 and a radius of 11. Its area was 179 feet squared. So we're taking now the walkway and increasing it by 1 foot. And if you increase it by 1 foot, that means that you are increasing the radius by 1 foot, making the radius now 12. So we want to compare the areas. The fountain stayed the same. The walkway increased. So the fountain was the area is pi r squared, or 3.14 times 8 squared, which gave us 200.96. The area for the large circle to get the walkway now will be pi times 12 squared, because the new radius for the larger walkway is 12. Squared is 144, and you'll be multiplying that by 3.14, which gives us 452.16. We now need to get the new area of the walkway, so we'll take 452.16 and we'll subtract 200.96, which gives us 251.2. But because we want to know how much did the area of the walkway increase, we have to subtract the original area, which was 179. And you get 72.2. So the walkway, by increasing it 1 inch, increased the overall area by 72 feet squared. Number 4 states the diagram below shows a doghouse that Calvino built. We want to know what is the volume of the doghouse. We know anytime that we are finding volume, we can use the formula that volume is the area of the base times the height. And we're looking at a pentagonal prism, which means that the base is going to be a pentagon. We don't have a single formula that we follow for the pentagon, so what we do is we break it down into familiar shapes, which in this case is a rectangle and a triangle. And if you combine those two areas, you'll get the area of the pentagon. The area formula for a rectangle is length times width. And the area formula for the triangle is base times height divided by 2. So now we can fill in those numbers to get the area of the pentagon. The pentagon is the front of this doghouse. So if we're looking at the rectangle is 4.5 feet long and 3 feet wide. So that's going to be 4.5 times 3. And 4.5 times 3 is 13.5. We'll then add that to the area of the triangle. And the triangle has a base of 4.5 feet and a height of 1.5 feet. So that'll be 4.5 times 1.5 divided by 2. 4.5 times 1.5 gives us 6.75. And when you divide that by 2, you get an area of 3.375. So the area of the rectangle was 13.5 and the area of the triangle was 3.375. So when you add those together, the entire area of the pentagon is 16.875. Now that we found the area of the base, we'll multiply that by the height of the prism. And the height of the prism in this case is the distance between the front and back pentagon. Three-dimensional shapes, especially right prisms, are named by their base. So whenever you're talking about the height of the prism, we're talking about the distance between the bases. So in this case, that's why it's the distance between the front and back pentagon. And the distance between the front and back pentagon is 4.5 feet. So we will take 16.875 and multiply it by 4.5, which gives us 75.9375. Which is our answer in A. 75.9375 feet cubed, because we're talking about volume. If you take a look at the work done in red, this shows you what it would be if you found the volume of the triangular prism on top and combined it with the volume of the rectangular prism on the bottom. You can see that you find the same volume regardless of whether you found the area of the base, which is the pentagon, times the height of the prism, or if you broke it down into two different three-dimensional shapes. You get the same answer either way. As we take a look at number 5, it says the figure below is a scale drawing of Quinto's bedroom. The scale used to create the drawing was 1/2 inch equals 4 feet. We want to know if the scale had been 2/3 of an inch equals 4 feet, how many more inches, excuse the typo, would the scale drawing of Quinto's bedroom have been? So when you see equivalent numbers, you should immediately think proportion. In the original scenario, we have 1/2 of an inch being equal to 4 feet. And we're saying that this picture we're looking at is a scale drawing of someone's bedroom. So you can see this portion that swings open, that's like a door. So we're looking for the dimensions of the actual bedroom, which form a rectangle. So when we draw on a sheet of paper, you can't draw the exact amount of feet, so you have to shrink it down, giving you the scale factor. So if 1/2 of an inch represents 4 feet in the room, and we have 2 1/4 inches, how many feet is Quinto's room? This is a proportion that can be solved. We'll cross multiply, giving us 1/2 x is equal to 4 times 2 1/4, which is 9. And when you divide 9 by 1/2, you get 18. So that means that Quinto's room is 18 feet. Now the scenario that we're given says if the scale factor had been 2/3 of an inch for 4 feet, how many inches longer would the scale drawing of Quinto's bedroom have been? His bedroom cannot change in size. It will still be 18 feet. We want to know now in the scale how many inches would we have taken up if the scale was 2/3 of an inch for every 4 feet. So again, you have a proportion. 4x is equal to 18 times 2/3, which gives us 12. And now to solve for x, we'll divide by 4 on both sides, leaving us 3. So that means now we would have taken up 3 inches. So we're looking for the difference between the 2 1/4 inches that's in our picture and the 3 inches that a different picture with a different scale would have created. And the difference between 2 1/4 and 3 is 3/4 of an inch. So the correct answer here is C. Next, we want to use the following numbers for 6 and 7. Justin made a scale drawing of a rectangular playground. He used the scale 2 centimeters is equal to 3 feet. His drawing is 18 centimeters by 24 centimeters. So we can draw what this might look like. It's a rectangular playground with dimensions of 24 centimeters and 18 centimeters. We want to answer the question that says, what is the actual area of the playground? And this is a rectangle, so we're going to do area is length times width. And this playground is not built in centimeters. That would be extremely small. It's built in feet. So we're going to use our scale or proportion that 2 centimeters is the same as 3 feet. So the side that is 24 centimeters will be how many feet? And if 2 centimeters is 3 feet, then the side with 18 centimeters will be how many feet? So again, this goes back to our proportional reasoning and solving and setting up proportions. So first we would take our 3 and multiply by 24. And 3 times 24 is 72. So 72 will be equal to 2x. We'll divide by our 2, giving us 36 feet for x. So our side that is 24 centimeters is 36 feet long. For the side that's 18 centimeters, we'll take 3 and multiply by 18, which is 54. And 54 will be equal to 2x. 54 divided by 2 is 27. So our side with 18 centimeters is equivalent to 27 feet. Which means if we want to find the actual area of the playground, we would do 36 times 27, which is 972. So that's 972 feet squared, which is A. All right, for number 7, it says, suppose Justin used the scale 7 centimeters is 9 feet. What would the dimensions of his drawing be? So again, we're looking at proportional reasoning. That 7 centimeters is equivalent to 9 feet. We know the dimensions of the actual playground. The playground is 27 feet by 36 feet. We want to know what would the new dimensions of his drawing be. So we're looking to find the amount of centimeters that would be in 27 feet. And again, if 7 centimeters is equivalent to 9 feet, we're looking to know how many centimeters would be in 36 feet. Because the size of our playground will not change. It's our drawing that would change. So now as we solve this, we would do 7 times 27, which is 189, and that's going to be equal to 9x. 189 divided by 9 leaves us with 21. If we come to our other proportion, 7 times 36 is 252, and that's going to be equal to 9x. So when we divide by 9, 28 is equal to x. So our drawing would be 21 centimeters by 28 centimeters. We're told to use the following for numbers 8 through 11. It says a model of a symmetrical garden shed is shown below. We first want to know what is the area of each square face of the shed. And when you look at the square faces, squares have the same dimension for length and for width. So the square faces are 8.4 by 8.4. So that is also the same thing as saying 8.4 squared, because that's what you're doing when you're multiplying something by itself. And 8.4 squared, or 8.4 times 8.4, is 70.56. So that is C. And number 9, we're asked what is the area of each triangular face of the shed. And the triangular face makes up the roof, which this base measure is going to correspond with the bottom here of 8.4, and the height is 4. So again, the area formula for a triangle is base times height divided by 2, which means 8.4 times 4 divided by 2. 8.4 times 4 is 33.6. And when you divide that by 2, you come up with 16.8, which is A. Number 10 asks, what is the area of each rectangular face of the shed? The bottom of the shed is a cube, so every face of that is going to be a square, but the rectangular face is made up from the roof. So the rectangular face is 8.4 by 5.8. And when you multiply 8.4 times 5.8, you get 48.72. Which is D. The next question says, what is the surface area of the shed, including its floor? So you have to keep in mind what the area of the faces were. And then you're going to account for the numbers the right amount of times to cover all of the surfaces of the shape. So I've broken the shape down into the base, which was a cube, and the roof, which was a triangular prism. The square, or the base, the cube, has 5 squares that we're going to use for the surface area, because you're going to account for the left and right side, the front and the back, and the bottom. So 5 of those sides will be used toward the surface area. The next piece is the triangle, and the triangle helps to compose the roof. And there are two of them, one in the front and one in the back. And the rectangles are on the sides of the triangular prism. So again, there are two of them. So now that we've accounted for all of the sides, we'll carry out the multiplication and then add them all together to get the total surface area. When you take 70.56 and multiply by 5, you get 352.8. When you take 16.8 times 2, you get 33.6. When you multiply 48.72 times 2, you get 97.44. So now when you add them all together, you get 483.84. And again, because it is area, that would be feet squared. We're going to use the following for numbers 12 through 14. A scale drawing of a rectangular playground has a length of 20 inches and a width of 10 inches as shown below. The scale is 1 inch is equal to 15 feet. We see equivalent numbers, we should start thinking about a proportion. We want to know what is the area of the scale drawing of the playground. Well, the scale drawing is a rectangle, and area for a rectangle is length times width. And we have 20 by 10 as the dimensions, which gives us 200 square inches for that picture. The next question says, what are the length and width of the actual playground? Show your work and draw the picture. So again, this goes back to the proportional reasoning that 1 inch is 15 feet. So if we have a length of 20 inches, how many feet is that? Well, we'll solve the proportion. 15 times 20 is 300. And 300 is equal to 1x or just x. So if the length is 20 inches, then it is the same as 300 feet for the actual playground. For the width, again, we have a scale of 1 inch is 15 feet. So if we have 10 inches, how many feet is that? 15 times 10 is 150. And 1 times x is x. So the width of 10 inches is 150 feet. Number 15 says the figure below is composed of two right triangles. We want to know what is the area of the figure in square inches and show your work. So the figure has an area in this triangle and an area in this triangle as well. The area formula for a triangle we know is base times height divided by 2. So we will do that twice and then combine our answers for the composed picture. So in the small right triangle, the measures are 3.2 inches by 2.4 inches. So when you multiply 3.2 times 2.4, you get 7.68. And when you divide that by 2, you get 3.84. You'll do the same thing for the larger triangle, this time with measures of 10 inches and 7.5 inches. And then you'll divide that by 2. So 10 times 7.5 is 75. And 75 divided by 2 is 37.5. So now if you want the area of the composed figure, you'll add your 3.84 with your 37.5. to get 41.34 square inches, or inches squared. Remember, with a triangle, the base and height are determined where the height meets the base at a right angle. So it does not matter in the case of the small triangle whether you call your 3.2 your base or your 2.4 your base, because they meet at a right angle. That's the same thing with your larger triangle, 10 and 7.5. You know that those are the correct measures to use because they meet at a right angle. We're going to use the following numbers for 16 and 17. The diagram shows a birdhouse Michael is building. The lower part of the birdhouse is a cube, while the upper part is a triangular prism. Michael wants to know how much space there will be inside the birdhouse, so he calculates the volume. What is the volume of the birdhouse? And show your work. So again, this birdhouse is in the shape of a pentagonal prism. So we're going to find the volume by multiplying the area of the base times the height. And that base breaks down into a rectangle and a triangle. The rectangle is 11.5 by 11.5, or we know that that's going to be 11.5 squared. The triangle is 11.5 by 7.4. But because it's a triangle, we have to divide it by 2, since it's base times height divided by 2. So 11.5 squared is 132.25. And again, 11.5 squared is the same as saying 11.5 times 11.5. And we will add that to 11.5 times 7.4, which is 85.1. We'll divide that by 2 to get 42.55, which is the area of the triangle. So together, they will give us the area of the pentagon, which is our base. So 42.55 plus 132.25 is 174.8. Now that we have the area of the base, we'll multiply that by the height of the prism. And the height of the prism is the distance between the front pentagon and the back pentagon, which is 11.5. And 174.8 times 11.5 is 2010.2. So the volume is 2010.2 cubic inches. For number 17, it says on one wall, Michael will make an entrance hole with a 1.5 inch diameter. What is the area of the entrance hole rounded to the nearest tenth of a square inch? And show your work. So we're saying that we're going to make a space for the birds to enter. And it's going to have a diameter of 1.5. If it has a diameter of 1.5, then it's going to have a radius of half of that. And 1.5 divided by 2 is 0.75. And if we're going to find area of a circle, then that is pi times the radius squared. We use a measure that is consistent for any person, regardless of the type of calculator that they have. So we'll have 3.14 times 0.75 squared. 0.75 squared is 0.5625. And when you multiply that by 3.14, you come up with 1.76625, which would round to 1.8. So 1.8 square inches.